Hi everyone, this is teacher Tianshi and welcome to our last day of the practice problem. And I'm so happy that lots of you did the entire 7 days of the practice problem, and let's get ready for the Algebra 1. So here is our last day of the practice problem, and first of all, I would like to introduce two important definitions about numbers, and the first is called the greatest common factor. So actually the definition for the greatest common factor is the largest factor that all numbers share. For example, the greatest common factor for 2 and 6 will be 2, because this is the largest factor that all numbers share. And there is another definition about numbers which is called the least common multiple. So actually the least common multiple is the smallest multiple that two or more numbers have in common. So for example, the least common multiple for 3 and 4 will be 12. And the reason is that this is the smallest multiple that two numbers share in common. So this is about a little bit review. And here let's talk about these questions in the practice problem. So for this question, we know that dividing a certain two-digit number by 3 leaves a remainder of 2, and dividing it by 11 leaves a remainder of 2 as well. So what is the smallest possible value of this number? So in that case, we know that some number, so we can assume it to be maybe x, and then divided by 3, it equals to some number, and the remainder is 2. And if we divide it by 11, it also has some number, and the remainder is also 2. So if we subtract the 2 from this number, then actually this number will be divisible by both 3 and 11, right? So what is the least common multiple for 3 and 11? Actually, the number will be 33, right? So this number subtracted by 2, the least possible value is 33. So the smallest value for this number will be 33 plus 2, which equals to 35. So in that case, for this kind of problems, first of all, we can translate the word into the algebraic expression, and then we can think about the divisibility of this kind of thing and related it into the concept of least common multiple, and then we can find the smallest possible value of this number. So this is about this question, and we also have the last question, which is AMC8 problems. So this question asks us which of the following number is not a perfect square. So what is the definition about the perfect square? A perfect square is a number which is a square of an integer. So for example, 1, 4, 9, 16, these kind of numbers are the perfect square number. And the perfect square is a number multiplied by itself. So it can be written in the form of some number squared, right? So if the exponent can be written in the form of something squared, then something related to 2, then it can be expressed in the form of the perfect square. So for example, 1 is 1 squared, and 4 is 2 squared, and 9 is 3 squared, and 16 is 4 squared, right? So the perfect square number can be written in the form of some number, and the exponent can be written in the form of 2 times something. So in that case, if the exponent is an even number, then it can be written in the form of the perfect square. So for example, this one, it can be this is an even number, like the exponent 2016 is an even number, and it can be written in the form of 1 to the power of 1008, and then to the power of 2. So it can be written in the form of the perfect square. So we can now choose A. And for B, the exponent is an odd number, meaning that this cannot be written in the form of the perfect square, right? Because if we rewriting it in the perfect square form, then it can be 2 to the power of 2017 divided by 2, and then to the power of 2. And this is not an integer. So the B is not a perfect square. So B does not make sense. And what about C? So C, the exponent is an even number, and actually we can rewrite it in the form of 3 to the power of 1009 and to the power of 2. So this is the number 3 to the power of 1009 multiplied by itself. So this is a perfect square. So C is a perfect square, so we can now choose C. And for D, even if the exponent is an odd number, but actually we can write it in the form of 4 to the power of 2019 divided by 2 and then to the power of 2. And here, 4 is already a perfect square, and it can be written in the form of 2 squared and then 2019 divided by 2 squared. So in that case, this number can be written in the form of 2 to the power of 2019 squared. So this is a perfect square number. So D does not make sense. And let's talk about E. So for E, this number, like the exponent, is already an even number, and we can write it in the form of 5 to the power of 1010 and then to the power of 2. So this is the number 5 to the power of 1010 multiplied by itself. So this is a perfect square, so we can now choose E. And the only possible answer for this question will be B. So for this question, we can find the connection between whether the number is a perfect square and whether the exponent can be written in the form of the even number. So if we can rearrange the number and make the exponent to become an even number, then it can be written in the form of the perfect square. But if in any case the exponent cannot be written in the form of an even number, then this number is not a perfect square. Yes, so this is about this question, and I hope you enjoyed our weekly practice problem, and I'm looking forward to seeing you in the future. Bye.